Section 8.2, special right triangles. And in this section, my special right triangles are going to have angle measures of 30 degrees, 60 degrees, and 90 degrees. And an isosceles right triangle with measures of 45 degrees, 45 degrees, and 90 degrees. On this slide, I have three diagrams. Three isosceles right triangles, therefore 45, 45, 90 right triangles. I can use the Pythagorean theorem to find missing sides, or use the definition of an isosceles triangle to know the side measures. For example, if this is 7 and this is 7, both legs are congruent, I can determine the hypotenuse. Here I know the hypotenuse, but if I let one unknown leg be x, the other one is congruent to it, so therefore that is x. Here, one of the congruent sides is 2 square roots of 3, so I know the other is 2 square roots of 3, and I can determine the hypotenuse. In each case, I can find the value of x by the Pythagorean theorem. I've already done that. And here I have the legs of 7, hypotenuse 7 square roots of 2, the legs 5, the hypotenuse 5 square roots of 2. And here, my legs are 2 square roots of 3, and my hypotenuse is 2 square roots of 6. Notice something common is going on in each one of my 45, 45, 90 triangles. On this slide, I have measures of 30, 60, 90 for each right triangle. And I can determine the missing legs on these two triangles by the Pythagorean theorem, by letting the legs be x. And here I can determine the hypotenuse by letting the hypotenuse be x. And again, I can find those values of x by the Pythagorean theorem. I've already done that. And notice on this, I have a leg which is 2. As a matter of fact, it is the shortest leg in my diagram. And the hypotenuse is 4. And the longest leg in the diagram is 2 square roots of 3. My shortest leg is 5. And the hypotenuse is 10. And the longest leg is 5 square roots of 3. Here, my shortest leg is 4. My hypotenuse is 8, and my longest leg is 4 square roots of 3. Again, some common thread being formulated through a 30, 60, 90 triangle. Theorem 8.5 verifies that thread through a 45, 45, 90 triangle. In a 45, 45, 90 triangle, I have both legs are congruent, and the length of the hypotenuse is square root of 2 times the length of a leg. Therefore, if I'm given a 45, 45, 90 triangle, in other words, an isosceles right triangle, I know the legs are congruent. And to determine the hypotenuse, I take the measure of the leg and multiply by the square root of 2. Therefore, if this was 3, I know the other leg would be 3. And the length of the hypotenuse is just the square root of 2 times the length of that leg, which would be 3 square roots of 2. The other formula is used in a similar fashion. Notice on this one, I knew the length of a leg. Therefore, I could determine the length of the hypotenuse. Here, what if I'm given the hypotenuse? I'll make that hypotenuse length 8, and I want to determine the length of the leg. I just let the leg equal x, and I know they're both congruent, so they're both x. And all I do is take the hypotenuse divided by the square root of 2. So here, 8 divided by the square root of 2. I know from previous sections that I am not allowed to have a radical in the denominator, and I need to rationalize, which means multiply the top and bottom by that radical. When simplifying, I get 8 square roots of 2 over the square root of 4. But the square root of 4 I know is 2. And then simplify the final time, I get 4 square roots of 2. So therefore, each formula can be used. It all depends on what I need to find and what I am given. If I'm given the leg, I could find the hypotenuse by multiplying by the leg by the square root of 2. If I'm given the hypotenuse, I can divide the hypotenuse by the square root of 2 to determine the leg. Before we proceed to the theorem on a 30, 60, 90 triangle, we have to identify the parts of the 30, 60, 90 triangle. Here we have the right angle, and of course we know in any right triangle, the side opposite the right angle is the hypotenuse. and therefore we know that the other two segments must be the legs. We have to identify specifically which is the short leg and which is the long leg. Recall in a previous chapter we know that the shortest segment would have to be opposite the smallest angle. And here, since 30 degrees is my smallest angle, this must be my short leg. So the segment opposite my smallest angle is my shortest leg. And opposite my 60-degree angle would be my long leg. But of course, my longest segment in the triangle is opposite the largest angle, which is the hypotenuse. But we need to be very specific on identifying the parts. The short leg, opposite the 30-degree angle, the long leg, opposite the 60-degree angle, and the hypotenuse opposite the right angle. Let's take a look at the theorem that is on the 30, 60, 90 triangle, which is theorem 8.6. This states that in a 30, 60, 90 triangle, the hypotenuse is twice the length of the shorter leg. The length of the longer leg is square root of 3 times the length of the shorter leg. As in the 45, 45, 90 triangle, you need to write these down and put them to memory because we have to know the formulas to find the values of specific segments in both of our special right triangles. Here, if I know the short leg in my right triangle, then I know that the hypotenuse is 2 times the short leg. The long leg is square root of 3 times the short leg. So these two formulas are very simple as long as I know my short leg. But what if I'm not given my short leg? If I need to find my short leg, then I need to determine the short leg based on the segment that is given to me. If I'm given the hypotenuse, I take the hypotenuse divided by 2 to get the short leg. Then I can go back to one of these formulas to determine the long leg, which would be the short leg times the square root of 3. If I'm given the long leg, I take the long leg divided by the square root of 3 to get the short leg. Then I go back to this formula to determine the hypotenuse, which is the short leg times the square root of 2. So you need to have written down 3 sets of formulas, one for the 45, 45, 90, one for the 30, 60, 90 if I'm given the short leg, and a set for the 30, 60, 90 if I need to find the short leg. And let's use these to solve the next set of examples. You should have those formulas written down as we work through these examples. Here, we want to find the value of each variable. If your answer is not an integer, leave it in simplest radical form. In this right triangle, I know it is a 45, 45, 90 because my 2 legs are congruent. Therefore, since the legs are congruent, this is 6. Y is equal to 6. And from one of our 45, 45, 90 formulas, I know the hypotenuse is equal to the leg times the square root of 2. Therefore, this is 6 square roots of 2. Again, I'm given a 45, 45, 90 because if this is 45 and this is 90 by the triangle sum theorem, I know that this is 45 degrees. I'm given the hypotenuse, and I need to find the value of x and y. But in this situation, I know that they are congruent because this is an isosceles right triangle. In a 45, 45, 90 triangle, I know from our formulas that the leg is equal to the hypotenuse divided by the square root of 2. Therefore, this is going to be 12 divided by the square root of 2. I'm not allowed to have a radical in the denominator. I rationalize. That means multiplying the top and bottom by that radical. And when I simplify, I'm going to get 12 square roots of 2 over the square root of 4. But that gives me 12 square roots of 2 over the square root of 4 is 2. Simplify, I get my leg equal to 12 divided by 2, 6 square roots of 2. My next example, I have to find the value of x and y again. I'm given a 30, 60, 90 triangle. Here, I know that this is my 30-degree angle. This is my short leg. This is my 60-degree angle. This is my long leg. And this is my hypotenuse. So I'm given the hypotenuse. Recall, if I don't have a short leg, I have to find a short leg. And since I have the hypotenuse, my short leg is equal to the hypotenuse, which is 7, divided by 2. Now that I'm given my short leg, I can find the long leg by multiplying my short leg, which is 7/2, times the square root of 3. Therefore, my long leg is 7/2 square roots of 3. Now I can go back in and verify each variable. My short leg is 7/2, and my long leg is x, which is 7/2 square roots of 3. On the next example, again, I'm given a 30, 60, 90. I need to verify the segments of the triangle. I know that x is my hypotenuse. I know that y is my short leg. And I know that 6 is my long leg. And I know in a 30, 60, 90, I need to determine the short leg first if I don't have it. Therefore, the short leg is equal to the long leg, which is 6, divided by the square root of 3. Simplify, rationalize, multiply the top and bottom by the square root of 3. I get 6 square roots of 3 all over. The square root of 3 times the square root of 3 is the square root of 9, which is 3. Therefore, this is 2 square roots of 3. So my short leg, which is y, is 2 square roots of 3. To find the hypotenuse, I just take my short leg, which is 2 square roots of 3, and multiply that by 2. 2 times 2 is 4 square roots of 3. My hypotenuse is 4 square roots of 3. On this diagram, I need to find the value of x and y again. I know that I'm given a 30, 60, 90 triangle. Here, I have a 30-degree angle. Therefore, my short leg is the square root of 3. My long leg is y. And my hypotenuse is x. Since I'm given the short leg, I can find the hypotenuse by multiplying my short leg times 2. Therefore, that's 2 square roots of 3 for the length of my hypotenuse. And my long leg is my short leg, which is the square root of 3, times the square root of 3. Therefore, my long leg is equal to the square root of 3 times the square root of 3 is the square root of 9, which is 3. On my next diagram, I have a 45, 45, 90 triangle. Therefore, this is an isosceles right triangle. Automatically know that the legs are congruent, and that tells me that x is 2 square roots of 6. To find the hypotenuse in a 45, 45, 90, I'm going to multiply the leg, which is 2 square roots of 6, times the square root of 2. That gives me 2. The square root of 6 times the square root of 2 is the square root of 12. But that can break up into 2 factors, one being a perfect square. 2 times 4 times 3. The square root of 4 is 2. 2 times 2 is 4 square roots of 3. Therefore, the hypotenuse is 4 square roots of 3. In this diagram, I have 4 congruent sides with 4 right angles. Therefore, I'm given a square. That tells me that this is going to be a 45, 45 isosceles right triangle. And here I am given the hypotenuse. I can determine the leg by taking the hypotenuse, which is the square root of 5, and divide that by the square root of 2. Rationalizing, multiplying the top and bottom by the square root of 2, gives me the square root of 10 over square root of 2 times square root of 2 is the square root of 4. Square root of 4 is 2. And that is in simplest form. In my next diagram, I'm given a triangle with 3 congruent sides. Therefore, I know that this is an equilateral triangle, also equiangular. That tells me that all the angles are 60 degrees. Here I'm given an altitude, which is a segment from a vertex perpendicular to the opposite side. So I know I have a right angle. By the triangle sum theorem, 60, 90, this has to be 30 degrees. Then I can identify the sides of this 30, 60, 90 triangle. This is my short leg. The altitude is my long leg. And the known side is my hypotenuse. Since I have the hypotenuse, I can determine my short leg. Recall from the formulas, my short leg is my hypotenuse divided by 2 in a 30, 60, 90 triangle. This is in simplified form, 5 square roots of 2 over 2. Now I need to find the value of x, which is my long leg. My long leg is my short leg, which is 5 square roots of 5 over 2 times the square root of 3. And when I multiply, I'm going to get 5 square roots of square root of 5 times the square root of 3 is the square root of 15 all over 2. Again, no perfect squares when I find factors of 15. Therefore, this is in simplest form. My long leg is 5 square roots of 15 over 2. In the next diagram, I have multiple triangles joined together. On the left side, I have a 30, 60, 90 triangle. And on the right side, I'm given a 45, 45, 90 isosceles right triangle. I need to find the values of x, y, z, and v. The only known side is in my 30, 60, 90 triangle, and that is in my hypotenuse, which is 5 square roots of 3. I need to find the short leg, which is y, in my 30, 60, 90 triangle. X is my long leg in the 30, 60, 90 triangle. So let's find the short leg, as we always need to find first in a 30, 60, 90. The short leg is the hypotenuse, which is 5 square roots of 3 over 2. This is in simplest form. So my short leg is 5 square roots of 3 over 2. My long leg in the 30, 60, 90 triangle is going to be my short leg times the square root of 3. And when I multiply, I'm going to get 5 times the square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is 3. 3 times 5 is 15 over 2. So now I have my short leg and long leg in my 30, 60, 90. Since my short leg is 5 square roots of 3 over 2, I know that z is 5 square roots of 3 over 2 because this is an isosceles right triangle. The legs are congruent. Now, since I know a leg in my 45, 45, 90 triangle, I can determine the hypotenuse in my 45, 45, 90 triangle. The hypotenuse is equal to my leg in the iso right triangle, which is 5 square roots of 3 over 2, times the square root of 2. And that gives me, when I simplify, 5 times square root of 3 times square root of 2 is the square root of 6 all over 2. And this is in simplest form. So now I have all the values for x, which is 15 halves, y, which is 5 square roots of 3 over 2, z, which is 5 square roots of 3 over 2, and v, which is 5 square roots of 6 over 2. In this example, Sue forms a peace sign with 3 straws. The straws meet at 120 degrees. Each straw is 4 square roots of 3 inches long. Find the length between the tips of the straws. A peace sign without the circle looks like this. It's stated in the diagram that I have an angle formed by the straws of 120 degrees for each of these angles. I know the length of a straw is 4 square roots of 3, and I need to determine the distance between the tips of the straws. The easiest way to do this is to drop an altitude from one vertice. That will give me a right angle. That gives me a right triangle. And I know that this entire angle is 120 degrees. This altitude will bisect that, making this a 60-degree angle. Now, by the triangle sum theorem, I know I have a 30, 60, 90 triangle. Here is my short leg. It's opposite my 30-degree angle. My long leg is from the tip to the altitude. That's my long leg. I need to find my short leg and my long leg and then determine the distance between the two tips. I'm given the hypotenuse, so I need to find my short leg first, and that was demonstrated back in my formulas. My short leg is my hypotenuse, 4 square roots of 3, divided by 2. Therefore, in this problem, my short leg is 2 square roots of 3. My long leg is equal to my short leg, which is 2 square roots of 3, times the square root of 3. That tells me my long leg is equal to square root of 3 times the square root of 3 is the square root of 9. Square root of 9 is 3. 3 times 2 is 6. So, the distance from the tip to the altitude is 6. I know that these two triangles are congruent because of side, angle, side. Therefore, I know that this is 6. Therefore, from tip to tip must be 12 inches. On the last example, a pulley system between the ground and the loading door on the second floor of a barn is 22 feet long. The pulley makes a 60-degree angle with the ground. Here I have a barn. Here's the door. And I have a pulley system going from the ground to the door. That pulley system is 22 feet long. And I know that the pulley makes a 60-degree angle with the ground. And assuming that the barn is perpendicular to the ground, I know that I have a right angle. Therefore, I know by the triangle sum theorem, I have a 30, 60, 90 degree triangle. Part A, they want me to find the height of the loading door off the ground. Well, in a 30, 60, 90 triangle, the loading door is identified as my long leg. Therefore, since I'm given the hypotenuse, I need to find my short leg first and then find my long leg. Recall from my formulas, my short leg is going to equal my hypotenuse, which is 22, divided by 2. Therefore, my short leg is 11 feet. My long leg, which is going to be the height of the door off the ground, is going to be my short leg times the square root of 3, which is 11 square roots of 3 for the height of the door. 11 square roots of 3 feet. Part B. They want us to determine if the pulley rotates at 60 feet per minute. How long does it take for an object to go from the ground to the door? This is part A. Part B. Well, since I'm dealing with rate and time, I also have distance. So I have the formula D equals R times T. The rate is 60 feet per minute. So I know the distance is 22 feet. And I know my rate is 60 feet per minute. They want me to determine how long does it take, which is T. Then I just solve for T by dividing by 60 on both sides. And 22 over 60 can simplify into 11/30 of a minute. Therefore, my object will travel from the ground to the door in 11/30 of a minute.